This is an engineering mathematics question based upon group theory. Among these statements, we need to identify which of them is or are correct. It is an MSQ type question. First one says that x and y belong to group G such that xy the whole squared equal to x squared y squared. Then G is commutative or not, that is what we need to find out. Now we can expand this as xy dot xy equal to xx dot yy. Now let us multiply both the sides with inverse of x or x power minus 1. That will give us xy dot xy equal to inverse of x dot xx dot yy. Now we can cancel out these two. Same on this side. That gives us y dot xy equal to x dot yy. Now let us repeat the same thing with the inverse of y. We'll multiply that on both sides. Y dot xy y inverse. Now at the right hand side, y and y inverse. So now we can cancel out these two from both the sides. The result we get is y dot x equal to x dot y. Hence this group G is commutative, that we have proven. So option A is true. Now looking at option B, it is saying that x belongs to group G such that x squared equal to 1. 1 means it is an identity element. If x squared is 1, which means identity, then x will be inverse of itself. We can say that x equal to x inverse. So we need to prove if G is commutative or not. Let us take this example. As we know, xy inverse can be written as y inverse dot x inverse. So now since every element is an inverse of itself, as we just saw, this can be written as x dot y, this can be written as simply y, and this can be written as x. So even here we got x dot y equal to y dot x. That is what proves that the group G is also commutative in this case. So option B is also correct. Now option C is saying that if the order of group G is 2, then it is commutative. Now 2 is a prime number. Every group which is having a prime order is also commutative. It is a cyclic group which will also be an abelian group, and all groups of such kind are always commutative. So again this statement is correct. Now option D is saying that if G is commutative, then a subgroup of G need not be commutative. This is false, because if that group is commutative, then it will also be abelian, and every subset of an abelian group is also abelian. So same applies for this case as well. Every subgroup of G also compulsorily needs to be commutative. Hence this option D is false. The correct statements we got are A, B and C. That is our answer.